Now in this fraction mathematics video lesson, we're going to discuss about equivalent fractions. Equivalent fraction. From the name itself, we are very clear, equi means equal, alright, and valent means the value. Alright, so those fractions which have the equal value, which have the same value, you can say, which have the same value, are called equivalent fractions. So same value fractions, all right, same value fractions are called equivalent fractions. But how does it, let's try to understand it properly. Okay, let's say I have a chocolate bar. This is my chocolate bar, and of the same length, exactly identical, the same chocolate bar, I bought another one. Okay, it's the same chocolate bar, and again I got another chocolate bar, all right, and let me buy one more chocolate bar, exactly of the same length and size, everything is same. Okay, all right. And what I'm gonna do now, I'm just gonna divide the first chocolate bar at the half, all right, here. This also I'm going to divide here, exactly. This also I'm going to divide here, exactly. This also I'm going to divide here, exactly. So these all are half. Now what I'm gonna do, I'm gonna eat this part. Okay, so there are two equal parts and I ate one part. So if I'm going to represent that into the fraction, and fraction is actually the part of a whole, a part of a whole. So how many parts we have? We have two parts here, and out of that I have eaten one. So I have eaten one out of the two parts, because the whole, in whole there are two parts, and the part I have eaten is one. So 1 by 2 is the fraction representation. Now what I'm gonna do, I'm gonna divide this half also again into the equal half. Okay, so what I'm gonna do, I'm just gonna split into the again half, and the another half also I'm going to divide again smaller half. Okay, so I had initially half and I break that also into the half. So now I have how many? 1, 2, 3, 4. 4 sections I have, and out of that I'm going to eat 2 sections. Okay, so I eat 2 sections out of the 4. Again, now what I'm gonna do, I'm gonna split that into the 3 sections. Okay, so 1, 2, and then 3. So here also 1, 2, and the 3. So these all are equal parts. All right, and now we have how many equal parts? Yes, we have 1, 2, 3, 4, 5, and 6. We have 6 equal parts, and out of that I'm going to eat 3 equal parts. I'm going to eat 3 equal parts out of the 6. Okay, and now I'm going to divide here into the 4 equal parts. 1, 2, 3, and then 4. 1, 2, 3, and the 4. And now how much we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 equal parts of the same chocolate bar. These all are same chocolate bar, having the same length and size. So out of these 8 equal sections, let's say I'm going to eat 4 equal sections. All right, so I eat here 4 sections out of the 8 sections. And can you tell me now how much chocolate actually I have eaten every time? Here I ate half chocolate, here I ate 2 by 4 chocolate, here I ate 3 by 6 chocolate, here I ate 4 by 8 chocolate. But all these fractions have the same value. All right, they all are the same value fractions, because they all represents the half. Eating 1 by 2, eating 2 out of 4, eating 3 out of 6, eating 4 out of 8, they all mean the same value of the chocolate I ate. So those same value functions, those same value fractions are called equivalent fractions. So these all are equivalent fractions because they all represent the same value. All right, having the value same and the different representation, that does not matter. That's the same. That's the equivalent fractions. So here 1 by 2, 2 by 4, 3 by 6, 4 by 8, they all represents the same thing. That's actually equivalent fraction. If you look at here, it's 1 by 2, right? and again I can equate 1 by 2 with 1 by 2, all right, and again I can equate 1 by 2 with 1 by 2, and again I can equate with 1 by 2 with 1 by 2. And let's see what happens if I multiply this 1 by 2 by 2 also and divide by also 2. All right, I can do this because I can easily cancel it. And here also I'm going to divide in numerator by 3 and denominator by 3. And here I'm going to divide numerator and here also I'm going to multiply by 4, and here also I'm going to multiply by 4. So this is 1 by 2, and 1 times 2, that is 2, and 2 times 2, that is 4, and again 1 times 3, that is 3, and 2 times 3, that is 6, and here 1 times 4, that is 4, and 2 times 4, that is 8. So what did we get here? We get that 1 by 2 is of the same value of the 2 by 4, is the same value of the 3 by 6, and have the same value like a 4 by 8. And even more, if you go, then it will be 5 by 10. If I'll multiply next time by 5 here, 5 and 5, I'll get 5 by 10. Next time if I'll multiply by 6 here also and 6 here also, then I'll get 6 over 12. And so on. If I'll multiply here by, let's say, 20, then I'll get here 20, and if I'll see same in the denominator also have to multiply by 20, so I'll get 20, so it will be 40. So these all have the same value, you know, looking so different. 1 by 2, 2 by 4, 3 by 6, 4 by 8, 5 by 10, 6 by 12, 20 over 40. It looks different, but they all have the same values, and they all represents the equivalent fractions. So no matter how they looks, but if the values of the different fractions looking different fractions have same, then those all fractions are called equivalent fractions. Okay, let's take another example. Suppose I have a biscuit, and I divided that biscuit into the 2 parts. All right, and now I'm going to eat half of that. Let's say half of that I ate. All right, so 1 out of 2. I had 2 equal sections. Out of that I ate 1. So this is 1 by 2. And if someone is saying, hey, you did not eat 1 by 2 fraction, he divided here again, and he made the 4 equal section, and he said, no man, you ate actually the 2 section, 1, 2, 3, 4. You ate the 2 section out of the 4. Again, I have to say, you're right, man. I ate the half of that. I ate this much sections. Whether you say 2 out of 4 or I would say 1 out of 2, both means the same thing. So these both are actually equivalent fractions. All right. And if I have a triangular like object, let's say triangular like chocolate, let's say this is chocolate. Again and again I'm telling chocolate. I really love chocolate. Hope you also. Anyways, so now see here. Again, I'm going to eat half of that. So that's 1 by 2. All right. So however is the the thing, whether it is in a triangle form, whether it is in the circular form, or it is in the square form. All right. Let's say it's square. Let's divide into the many sections. 1, 2, 3. 1, 2, 3. So altogether we have here 16 chocolate sections. This was a big chocolate, and I divided it into the 16 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if I'm going to eat half of them, half of them if I'm going to eat. So how many sections I ate here? I ate 1, 2, 3, 4, 5, 6, 7, 8. I ate 8 out of the total 16 sections. So again, either I'm writing 8 over 16 or 1 by 2 or 2 by 4. These all are equal. These all represents the equivalent fractions. Okay. So simply see here, if I have, let's say, 2 by 5. 2 by 5. And if I'm writing 2 by 5, and if I'm multiplying this by 2 and dividing also by 2, so actually by doing so, you can cancel it, and that gives the same meaning. So we can divide and multiply by the same number to any fraction. So I will get here now 4 over 10. So either you're writing 2 over 5 or 4 over 10, both means the same equivalent fraction. Or even if it is 2 by 5, you can multiply this by, let's say, 10, and here also by 10. So you'll get here 20 out of 50. So getting 20 marks out of 50 or getting 2 marks out of 5 is the same thing, and is same like getting 4 marks out of 10. So these all are same, and such kinds of fractions are called equivalent fractions. All right, and in the next video we will be trying to learn how to write the equivalent fractions, and then we will learn how can we convert into the lowest term, how to reduce a big equivalent fraction into the lowest term of that. Alright, these things we're going to discuss in the next video. See you in the next video. Goodbye, and don't forget to subscribe the channel.